What's x plus y to the 0? X plus y to the 1? It'd be a 1x plus a 1y, right? If you had x plus y squared, it would be x squared plus 2xy plus y squared. But and that's a 1x and a or 1x squared and 1y squared. As soon as I say that we're going to cube a binomial, you start to become angry. And it's really not that bad, but just try to unravel a little bit of how it works. And today's goal is for us to understand the binomial theorem. I'm not actually going to write out the whole binomial theorem. It's not that big of a deal, but generally we introduce that during courses like combinatorics and probability theory. For the sake of college algebra, we're really just going to use it for binomial expansion. So we're going to do x plus y to the 7th here very shortly. And right now, your brain is kind of hurting because you're like, I don't want to do x plus y to the 7th. I don't want to multiply it out 7 times. Well, we don't multiply it out 7 times. We have x plus y to the 3rd. It's going to start out as x to the 3rd. It's not going to be a 2. Forget about the coefficient. We'll talk about the coefficient in a second. But what about the variables? It's going to be x to the 2nd. And you're going to pick up a y. And it's going to be x to the 1st. And you're going to pick up a... And then you're going to pick up a y cubed. And the big question is, what are the coefficients? Yeah, it is 3. I will show you. First of all, what's important for you to note right now is not necessarily the coefficients, but the powers. Notice that we have 3, we have 2 plus 1 is 3, we have 1 plus 2 is 3, and we have 0 plus 3 is 3. So the degree of the monomial always ends up being that of our expansion power, okay? So the big question is, what do we do to generate the coefficients? Because my guess is we can expand x plus y to the 7th. We know we're going to start out with x to the 7th. We may not know the next coefficient, but we know it's going to be x to the, and then it's going to be x to the, and it's going to be x to the, sweet. Well, that's pretty cool. But the big question is, what are the coefficients? Kind of wonder, don't you? Triangle. And Pascal's triangle starts with a 1. And then we bring down a 1 on each end. So the first one has 1 term, then 2 terms. The next one has 3 terms. Again, there will be 1 on each end. But the middle number we create by adding the 2 above it. So 1 plus 1 is 2. So now I have a 1 on the front and a 1 on the end. And in order to create the middle 2 terms, I will add those together. And what do you get? 3 and 3. So do you see what the next one is? 1. Good. Then 1. Good. We'll go to 8. 1. 7. And 1, 8, 28, 56, 70, 56, 28, 8, and 1. This is Pascal's triangle, and you could carry it out as far as you want. There's some absolutely amazing, amazing pieces to it. But basically it tells us this. If you have a binomial to the 0 power, the coefficient is 1. If you have a binomial to the first power, the coefficients are 1 and 1. If you have a binomial to the second power, then your coefficients are 1, 2, and 1. Third power, 1, 3, 3, and 1. What we are concerned about for our problem right now is the 7th power. Well, there are coefficients. 1, 7, 21, 35, 35, 21, 7, and 1. And so we expanded x plus y to the 7th in a very short period of time. Can you say that again? It's good, because it saves us time, right? You like that, right? I want to help you become more efficient, and knowing the binomial expansion is going to help you save time as we move forward. Now, can I show you a couple small, cool things about it that might blow your mind just a little bit? So let's try to take this in. Successful moving forward. So let's try another one. We're going to do x plus y to the 5th. So I'm going to expand this. I have x to the 5th. Then what? Forget about the coefficients. Let's just do the variables. You got it, Rhiannon. So now all I need is the coefficients. And I know that the first one is always 1. I know that the second one is going to match that degree, so it's 5. And the second and the last one is 5 as well. So then I just really have to remember one more number. And I think I remember right. I think it's 10, isn't it? So all of a sudden, I mean, if we were to multiply out x plus y at 5th, I mean, that would have taken us a lot more time. We probably would have made a mistake in the process, right? So what if we don't have two variables? What if we have a number instead? I'm just going to create a and b, and I'm going to expand it as though it was two variables, a and b. If I do that, I get a to the 4th, a to the 3rd b, a squared b squared, ab cubed, and a to the 4th. I've made that mistake every hour. The number one mistake I make is always this last one. I always write the wrong term before. All right. Can't break it. All right, so what are our coefficients? Yeah, I see the 4 here, and so I know that the second to the last and the second one both going to be 4, so I just got to remember one more, and I do remember that's 6, so, you know, it's pretty easy to expand that. But now I don't have an a or a b. I have an x, so instead a to the 4th will be. And then what does this b become? It becomes 1, so I don't really need to worry about it, do I? So the b's don't need to be worried about at all because it's 1. So until the end. So I get 4x to the 3rd, 6x squared, 4x plus 1. So we expanded out x plus 1 to the 4th pretty quickly. Not too bad, huh? Flip it over. We're not going to do all these problems. We're just going to do a few more. We're going to do that one, and that one. Clinics is kind of flying around this day. A lot of kids battling colds and stuff. So I had a bunch stuffed up my nose yesterday, didn't I? Did anybody go home and tell their parents that I had clinics and stuffed up my nose? Just be honest. Anybody? You thought about it. So why didn't you? You were worried that they might call and complain then, or okay? It's too private. It's like what happens against the room stays against the room. Okay, well, this is A, so I'll leave it as A, and I'm going to write this as B. I have A to the fifth, A to the fourth B, A to the third B squared, A squared B to the third, AB to the fourth, and B to the fifth. In my coefficients, what coefficient do I know? I know the second one is 5. And I'm pretty confident then that these would be 10. So we're going to use the 2 here right now. I can leave the A alone. I do have an A to the fifth. But the B changes. B is 2. So it'll be 2 times 5 is 10. And then the 2 squared. So I have 40 A to the third. And then 80A squared. Plus 80A, and then 2 to the fifth is 32. Expansion done. Saves time, right? Let's do 2 more together. Yep, so now we see a minus. So I have A to the fourth, A to the third B, A squared B squared, B to the fourth. I remember that I'm going to have a 4. And then, yep, I've done enough where I remember the 6 now. 6 pairs with a 4. What? Wow. Like, it can take a lot of insults in life, but when Terry insults you, it goes deep. No, I'm hurt, Terry. I'll probably put in my letter of resignation tomorrow. So. All right. I'll be honest. So Terry. So as I work it through, every time, without a doubt, when I see the 4, I know the 4. But I don't know the 6 until I think of the 4 first. So I go to lay it out, 4 front and back, and then it does kind of trigger that the other one goes there. So anyway, I plug in the 2u, 2u to the fourth. This is college algebra, folks. 2u to the fourth. 16u to the fourth. I'm waiting. Now I'm going to use a -1 for b, and because I have just b and not b squared, this is going to turn to be negative, correct? So minus 32u to the third. Now I'm squaring b, so it will be positive 24u squared. B to the third, so it will be not too bad, huh? You try the next one, r plus 4s to the third on your own. Try that on your own, and I will get ready to hand out your assignment here, which is just a worksheet. It's just the front side. So Smaller amount of homework. Because I care about you. Okay, I got r to the third plus 12r squared s plus 48rs squared plus 64s cubed. Okay, so Lolly, can I give you a hint? So 16 times 4. Anybody else where that's something you don't like to do in your brain? Come on, admit it. Anybody? Okay, so here's what I do. Lolly, if I ever see a number that I don't like to multiply like that, here's what I do instead. 16 times 2, that's 32, right? Then we'll double to get 64. So, or if you wanted to, you could say that that's 4, right? That's 4 squared times 4, so it's 4 to the third. 4 to the third, 64. So lots of ways to think about it, right? I get